Okay, good morning. Welcome to
SummerMath24.
SummerMath number 24. Luckily, we found this little frisbee. It's going to help us in our problem. Okay, so we're on the chapter on counting sort of special situations. We did a little bit of correcting for overcounting.
Yep.
We counted pairs. And now this, the next section would be on counting, it's called counting with symmetries. Okay?
Yep.
So we have this question. In how many ways can 5 people be seated around a circular table if 2 arrangements are the same if everyone is sitting next to the same person? Okay, so let me show you what I mean by that. Okay, so just call people A, B, C, D, and E.
Alright.
A, B, C, D, E.
Yep.
That's going to be the same as this. A, B, C, D, and E.
Oh, I get it.
Okay, so you see everyone's sitting next to the same person. So this arrangement, just rotated, is the same.
Yeah.
Okay. Does this seem like a fun problem?
Yeah.
Yeah?
Well, I have an idea.
Okay.
Eat.
Wait. You understand the problem?
Yep.
Do you have any ideas?
Well, you can tell your idea.
Okay. Go ahead.
Well, the table can be rotated 5 different ways, because each person can go in 5 different places.
Okay.
So this is going to divide our total by 5.
Alright. Does that make sense to you?
Yeah. Well, then you can just ignore the restrictions and then divide by 5 at the end.
Ah, interesting.
Yeah,
Okay.
just act like it's a row.
Very interesting strategy. We have talked about counting in rows.
Yeah.
Now we're on a table. So one very good, I'm proud of you for saying that. One very good way to start on a problem with restrictions is pretend there aren't any restrictions.
Yeah.
Okay? So how many ways, can you tell me, how many ways can 5 people be arranged in a line?
It's 5 factorial.
Which we sometimes call,
120.
or
5.
5. Okay, 5 factorial. Now what?
Now we have to divide that by 5. So 120. Well, that would just equal 4 factorial.
Low 5. Good job.
24.
Okay? So interesting. Very interesting.
Because there is a 5 in here somewhere, and dividing by 5 will just take that out.
Very good. Very good. Alright, makes sense?
Yep.
Alright, but I got news for you. The problem in the book wasn't how many ways can 5 people sit around a table. It was how many ways can 10 people sit around a table.
Well, it's the same thing, really. Well, you just have to multiply it by 2. No, it's not. It's not multiplied by 2. It's 10 factorial over 10, which is 9 factorial.
9 factorial. So you see, ignore the restriction with the 10 people, and you put them in a line. You've got 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Yeah.
So it's 10 factorial.
And then divide the 10.
Divided by 10.
Yep. To get 9 factorial, we don't know what that is.
To get 9 factorial. Okay, now just last thing for a second. Let's go back to the 5 people sitting around the table. The way you can see the 4 factorial here is this. It's by noticing what you said. I can always rotate the table. So one way I like to think about it is to say, since I can always rotate the table, I'm going to just pretend that no matter what, A is in this position.
Yeah.
Okay?
Yeah.
So I'm just going to say, okay, A is in this position.
Then
how many slots do I have left with my 5?
you have 4 extra slots for.
I have 4 extra
inside the
slots. And now, by saying A is going to be in this spot, I've taken away any of the rotations.
Yeah.
Okay? So I can't rotate into another thing that's the same. So I've got 4 people for this slot, 3 for this, 2, and 1. So that's just a different way of thinking about it. And this counting with symmetries is a really interesting subject.
Yeah.
And there's, it was studied by a guy named George Polya. And one of the hardest questions, can you just grab a Rubik's Cube for me? One of the hardest questions on counting with symmetries was how many different ways can a Rubik's Cube be messed up? See, because you would want to count this arrangement as being the same as this arrangement, right?
Yeah. Yeah.
So there's 6 rotations around, and there's all sorts of other ways to rotate.
Yeah, and it turns out it's a like really, really big number.
Yeah, it turns out it's a huge number, but that was that's a fun. This is a very fun subject. So we'll talk a little bit more about it, next week.
Yeah.
All right. All right. Good job, guys. Good job.